In this video, we're going to talk about alternating series error bound. When we talk about alternating series error bound, we're talking about, let's take a look at this alternating series which converges, meaning that it has a finite sum. When you expand the terms, you get 1 minus 1 over 2 plus 1 over 3 minus 1 over 4 and so forth. You have infinite number of terms. So S represents the actual sum of the alternating series, and S of n is the partial sum of up to n, and R of n represents the remainder of the approximation or the partial sum. So for example, if you say S of 1, the partial sum of S of 1 will be just 1. And S of 2 is sum of 1 minus 1 over 2. And S of 3 would be adding first three terms. So 1 minus 1 over 2 plus 1 over 3. As you can see, as n gets higher, it gets closer to the actual sum and the remainder becomes less. So we have R of n equals the actual sum minus S of n. And the absolute value of R of n is equal to the absolute value of actual sum minus S of n. And we call this absolute value of R of n an error. So if we have an alternating series, convergent alternating series, then the error, absolute value of R of n, is less than or equal to A of n plus 1. Now A of n plus 1 is referred to as first neglected term. So in other words, we could say that the error is at most the size of first neglected term. So we have this alternating series which converges. By the way, there are two ways you need to show that alternating series converges. First, you have to show that limit as n goes to infinity of A of n equals 0. If it doesn't, then you know that this series diverges by n-term test. Second, you have to show that A of n is a decreasing function. In other words, A of n plus 1 has to be less than or equal to A of n. In this video, I'm not going to focus on showing the alternating series test converges because I already showed that in other video. What I'm going to do is I'm just going to focus on alternating series error bound. So let's say you want to find S of 2. That will be 1 minus 1 over 2. Our first neglected term is 1 over 3. Or you should say absolute value of 1 over 3, which is 1 over 3. So that means this approximation, the error will be at most 1 over 3. Now let's say you want to find S of 3. We should be adding these first three terms. And what is the first neglected term here? Then negative 1 over 4 is the first, actually absolute value of negative 1 over 4 is the first neglected term. So what does it mean? When you add these three terms, the error of this approximation will be at most absolute value of negative 1 over 4, which is 1 over 4. So as you can see, as you add more terms, you get closer to the actual sum and the error becomes less. Now let's take a look at this example. It says approximate the sum S of the alternating series so that the error is less than 0.001. So what we need to do is we need to find the first neglected term that will be less than 0.0001. So what you want to do is you want to find a term that gives you zeros, that has 4 zeros after the decimal point. And when you evaluate 1 over 4 factorial, that's approximately 0.041666. And this is not less than 0.001. So let's try 1 over 6 factorial. And when you evaluate 1 over 6 factorial, you get approximately 0.001388. And this is still not less than 0.001. So let's try 1 over 8 factorial. And we get 0.00002480. Now notice you have 1, 2, 3, 4 zeros. And this is definitely less than 0.0001. So this will be our first neglected term. So if you want to find the sum that has the error less than 0.0001, you need to add these 4 terms because you want that to be the first neglected term. So the sum will be 1 minus 1 over 2 factorial plus 1 over 4 factorial minus 1 over 6 factorial, and which is approximately 0.540. And of course, you have to probably use your calculator to find this value. And notice, when we talk about finding error of an alternating series, you need to show that this is a converging alternating series. Also, it's better to say that S of 4, because we had 1, 2, 3, 4 terms, S of 4 will have an error less than 0.001.